Question 4. Equal volumes of superheated steam at 450 degrees Celsius and 20 bars pressure are mixed with saturated steam at T2. Okay, you're not given the temperature. And 20 bars pressure. The product steam is at T3 and 20 bars pressure as well. Determine T2 and T3 assuming that the process is continuous at steady state and operates adiabatically. Now we draw out our system. We have the first one coming in and the second one coming in. Okay, both are steam. And then we have the steam coming out. Okay, so we write down our condition. So adiabatic flow system at steady state, in that case we assume that the change in kinetic energy equals to the change in potential energy equals to 0, and that equals to the work done. So therefore our energy balance becomes delta H equals to 0. So delta H is in minus the out. Okay, so we have your in here equals to out here. Okay, so we have your specific enthalpy here, which we have to multiply by its mass flow rate. Okay, if this is because this is in flow rate, enthalpy rate, so in the table we can only find it is only given in specific, so we have to multiply it. Specific means per kg. Okay, so we have to multiply it with its mass. Now given equal volumetric flow rate, okay, assume 1 meter cube per second, we need to calculate the mass flow rate. So for the first stream of our superheated steam, now from table B.7 we identify that V1 is equal to 0.163, H1 is equal to 3358, and M1, okay, we take the volumetric flow, divide by its volumetric specific volume, and that gives us with 6.135 kg per second. For stream 2, we will use the table B6 because this is saturated steam. Okay, so T2 is 212.4 degrees Celsius. Okay, we identify these based on the pressure, and V1 is 0.0995, H2, this is 222, okay, sorry for my mistake here, I'm so sorry. H2 is 2797.2, and M2, same thing, we take the volumetric flow, divide by the specific volume here, and that gives us 10.05 kg per second. Now using the energy balance that we did here, this one here, substitute all your values in. Substitute M, your H, M1, H1, M2, H2 equals to M1 plus M2 multiplied by H3. So we can solve for your H3. Now from table B.6 again, saturated steam at 20 bar, and this gives us T2 is equal to 212.4 degrees Celsius. Now from table B6, so this one is pretty direct, yeah, and we have already found over here. Now from table B.7, superheated steam at 20 bar. Now we have to look back at the H3 over here, since H3 is 3009. Okay, it lies between, if we look at the table, it lies between the temperature of 250 and 30 degrees Celsius. So you open table B.7, okay, check out H3, check out 20 bar, okay, check out their H in which the value lies smaller or larger than this value. Find the point where this value could belong, and you will notice that it lies between the temperature of 250 to 300 degrees Celsius. So we can obtain T3 by interpolating it at where T3 is 294 degrees Celsius at H3 equals to 3009.8 kilojoule per kg.